In this section, we're going to simplify expressions using our sum and difference formulas. So we're going to simplify the expression cosine x plus pi. So if we remember, this is our cosine of a plus b, and so that is cosine A cosine B minus sine of A sine of B. So we plug it in. So this is cosine of x cosine minus sine of x sine of pi. So the things that we do know is that we do know cosine of pi and we know sine of pi. So if we remember, let's think about the unit circle for a second. So with the unit circle, we know that at pi is here, and that value, the coordinate, is -1, 0, right? And the -1 is our x value, this is our y value, and remember that x is our cosine and y is sine. So let's fill this in. We know cosine of x, we could just leave that there, but cosine of pi is -1. And then minus sine of x times sine of pi is 0. So negative sine of x times 0, well, that becomes 0. So this answer is just negative cosine of x. So that is this simplified. Now let me just graph this just so you can see how this is related. So let's graph cosine of x first. So let's graph cosine of x. And 2 pi, pi over 2, 3 pi over 2, negative pi over 2, and negative pi. So cosine always starts at 1, right, or the amplitude, then down, 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 up, up. So here is cosine of x. So let's graph this one, cosine of x plus pi. So how is that shifted? That shifted left pi. Again, it starts at the 1, so 1, down, down, up, up, and let me do a couple more. So if you look at this graph, looking at just where we are at the origin here, we notice that the pink graph that we're seeing here is negative cosine of x. Okay, so we just simplified it to that. So what I want you to do is go ahead and try out number 6, 7, and 8 using the number 6 is the sum formula, 7 is difference, and then 8 is another difference formula. Okay, and then when you come back, I'll have the answers for you. So if you try these out, number 6, you would get negative sine of x. So you do sine of x times cosine pi plus cosine x sine of pi. Pi is, again, -1, 0. Cosine pi is -1. Sine of pi is 0, right? That's all you can substitute. Then this cancels out, so we're left with negative sine of x. Here you do this, and after all that, you get cosine of x. It should make sense because if you shift over right to pi, it's still the same function. Now tangent, remember that tangent is y over x. So tangent of pi, y over x, is our 0 over -1. So therefore, tangent of pi is 0. So wherever we see a tangent of pi, we're going to plug in 0. So remember the formula is tan of a minus tangent of b, 1 plus tangent of a times tangent of b. So you substitute. Then you replace the tangent of pi's with zeros. So then you get tangent of x minus 0 over 1 plus tangent of x times 0, and that goes away. So then it is tangent of x. Now let's go ahead and try solving trig equations. So if you notice, we have sine of x plus 3 plus sine of x minus 3 pi over 3 equals 1. And we're looking for values when it's in one period, so 0 to 2 pi. So what we're going to do is we're going to use the sum formula for sine of x plus pi over 3. So let's plug it in. Sine of x times cosine of pi over 3 plus cosine of x times sine of pi over 3. Then we're adding, let's do sine of x minus pi over 3, so do the same thing. Sine of x times cosine of pi over 3 minus cosine of x times sine of pi over 3, and that equals 1, right? So it equals 1 at the end. Now what I want you to notice is that the sign in the center, just to go over that again, is that this is just telling us what the sign is in the center, right? Which formula are we using? So this one we're using the difference formula, this is where we're using the sum formula. So just to make sure that you're not plugging a negative into these values here. Okay, that's not what it's telling us to do. Okay, so looking at this now, we have to look at what is pi over 3. Pi over 3 on the unit circle, well, that is about 60 degrees right here, pi over 3. So we want to know what our x and our y value is. So hopefully, you're starting to memorize these values. So let's look at it at pi over 3. So it's here, that's about 60 degrees. So remember, we need to remember what those values are on the unit circle. And at pi over 3, so the x value is close to the y-axis. So for me, I remember that's a half. And then the y value is root 3 over 2. Okay, so I know that it's closer to the y, so therefore the value is a little higher. So this is our sine, this is cosine and this is sine, and we could substitute that wherever we see these values. So let's plug it in. Sine of x times, what is cosine of pi over 3? Well, what I want to do is I actually want to write the cosine of pi over 3 first. So cosine of pi over 3 is 1/2, and then we go ahead and write our sine of x. Plus sine of pi over 3 is root 3 over 2 times cosine of x. Then let's do the rest. So cosine of pi over 3, we already know, is 1/2 times sine of x. So again, we're just bringing these values to the front. And then minus sine of pi over 3 is root 3 over 2, brings that to the front. And then times cosine of x, and again, that all equals to 1. Okay, so again, we're just evaluating what numbers we have. So for example, we know what pi over 3 is, and so we substitute, and then the x's just stay where they are. Now, what can we do with this? Well, we want to combine like terms. And so to combine like terms, we know that we have root 3 cosine of x and negative root 3 cosine of x. So what we could do with those is those just disappear. So let's cross those out. Now we have 1/2 of sine of x plus another 1/2 of sine of x. So let me write that out. It becomes 2, let's say 2 times 1/2 sine of x, right? We have 2 of them, and that equals 1. So what happens is just sine of x equals 1. Now we want to solve for that x value. When does sine of x equal 1? So again, sine represents what value? Sine represents the y value on the unit circle. So if we're looking at the unit circle, at what points is the y value 1? Well, it is 1 at this point here. And what point is that? Again, thinking about radians. Well, it is at 90 degrees or pi over 2. Okay, so that is the answer when we're solving this trig equation. Okay, another way to kind of look at it, you could look at it at the unit circle, which I think is really nice, but you can also, if you wanted to, you could graph it. And so let's just graph a period of sine. 1 and -1, sine starts at there. And we notice that at pi over 2, right, that is when the y value is 1. Okay, so that's another way to look at it. All right, let me do one more example here, and then you'll try the other two. So this is sine of pi over 4 times cosine of x minus cosine of pi over 4 times sine of x. So that's the first one. The second one is sine of x times cosine of pi over 4 plus cosine of x times sine of pi over 4, and that all equals 1. So let's simplify this. So what's nice is it's pi over 4, and so pi over 4, that's just root 2 over 2. So let's do that. Root 2 over 2 times cosine of x minus root 2 over 2 times sine of x plus cosine of pi over 4 is root 2 over 2 times sine of x plus root 2 over 2 times cosine of x, and that equals 1. So again, we want to combine like terms, and looking at this, we have our negative root 2 of sine and our positive root 2 of sine, and so those just cancel out. So now let's combine what we have left. We have here and here. So this is root 2 over 2 of cosine of x plus root 2 of 2 cosine of x, and that equals 1. So there's 2 of these, right? So this ends up being 2 root 2 over 2 cosine of x. The 2's cancel. And so we are left with root 2 cosine of x equals 1. So we need to isolate our cosine of x. So let's divide by root 2. So now we have cosine of x equals 1 over root 2, but we need to be able to rationalize the denominator. So when does cosine of x equal root 2 over 2? Thinking about that. So that is a positive root 2 over 2. So just knowing the values on the unit circle. Cosine is our x value, and it's positive. So really when we think about that, we can think about any of the values in quadrants 1 and 4. So think about it. At 45 degrees here, this is root 2 over 2 and root 2 over 2. Right? The x and y value is the same, and it's also positive. And also down here, that is still a positive x cosine of root 2 over 2, and our y value is negative root 2 over 2. So we need it in radians. So it's however you can figure out how that is. Now I know this one here, so x equals, so one of our answers, x equals pi over 4. Okay, x equals pi over 4. Then you need to find out what it is here. So, number one, you can either find the degrees and do that. Another way to do it is how many fourths are there to get there. So you have one, here's another one, another one, another one here and here. So that's 1, 2, 3, 4, 5, 6. So 6 over 4, so add 6. That ends up becoming 7 pi over 4, okay? Or you know that its full period is 2 pi, you can subtract pi over 4, right? Because this is negative pi over 4, and that'll also give you 7 pi over 4. It's however you can think about it, but we are in radians, okay? So you must give me the answer in radians. So cosine of x equals root 2 over 2 when it's pi over 4 here, and when it's 7 pi over 4. So I want you to go ahead and try out these last two, number 13 and 14. Pause the video, and then I'll give you the answers. All right, so I hope you tried this out. Number 13, the answer is just pi, so looking at the work here. And then for number 14, it's interesting, right? So you probably got down to here, negative cosine of x plus sine of x equals 0. So what you want to do is add cosine x to both sides. So when is it when sine of x equals cosine of x? Well, when do they have the same value on the unit circle? Well, that's at the 45 degrees, right? But they have to both have the same sign. So it is true when it's root 2 over 2 and root 2 over 2. That's in quadrant 1, and that is pi over 4. Then it happens again in quadrant 3, where if sine is negative root 2 over 2, then cosine is also negative root 2 over 2. So at those two spots. So the answers here is x equals pi over 4 and x equals 5 pi over 4. Again, when you're looking for these, make sure that it's in radians. Make sure it's in the 0 to 2 pi range, whatever it gives you. I hope this helps you out. Thanks for watching.